Okay, as previously mentioned, we are working through Chapter 3, Section 2 today, part of it anyway. The notes up on the screen are the notes that I shared out on Google Classroom. We're going to keep it relatively simple today because we are incredibly close to winter break. And you will have an assignment on quizzes just to cover this material. More or less what we're talking about today is how we use our calculator to solve logarithmic equations. Okay, so anytime we're dealing with solving equations, it is often, in many ways when we get up here where we are in pre-calculus, there are often ways to make those equations simpler by converting them into a different form. This is especially true when we're working with our exponential and logarithmic equations, which are opposites of each other. Remember that every time we solve for a variable in any equation, we are trying to get that variable completely by itself, which we already know. I mean, we've got all these tricks and tips to go through that we can do that. The big thing is when we solve an equation, we are often doing the inverse operation in order to isolate the variable, in order to get the variable by itself. If we have x plus 3 equals 5, then we subtract 3 from each side to get rid of plus 3, because addition and subtraction are inverse operations, which is where logarithms come in. Okay, exponentials and logarithms are inverse functions. Okay, exponentials and logarithms are inverse operations. So if we need to undo an exponential, if we need to get a variable down from being an exponent, we need to take a logarithm. And if we need to get a variable out of a logarithm, we raise it to an exponent. Okay, just like we do with addition and subtraction, these are opposite operations of each other. So when we do this, a lot of the simpler problems, we do this just by converting the equation into a different form. Okay, there are two different ways we might need to convert. We might need to actually convert from a logarithm to an exponential, or vice versa. And then for logarithms, we also have the change of base formula. And these are the two things that we are going to discuss in class today. So I'm just going to grab a quick screenshot here and throw that into our completed notes. Give me just 1 second here. There we go. Get it cleaned up later when it's time to use it. All right, so that's what we're doing here today. We're talking about these two things. We're talking about solving logarithmic equations by converting them into exponentials, and we're talking about evaluating logarithms using the change of base formula. Okay, should be a relatively simple day. It's 95% calculator work. Should be a relatively simple assignment and a good thing to go on to break with. Okay. So we're going to continue here. If nobody has any questions, ask now or forever be annoyed that I moved on to the next portion of the lesson. You can unmute and ask. You can drop it in the chat. What do you got for me? Any questions so far? And we're talking logarithms. Logarithms and exponentials are inverses of each other. You should have some passing understanding of logarithms from Algebra 2. Okay. So the first thing we're going to discuss here is converting between logarithmic and exponential form, which is shown here in this box. We've got the logarithmic form on the left. That's logarithmic form. Log base b of n equals x. And on the right, we have the exponential form. These two equations are identical. They're just written in two different forms. They are equivalent. They mean exactly the same thing. Okay, b is the base, x is the exponent, and n is the numerical value of b to the x. Okay, so b is the base, n is the numerical portion, and x is the exponent. Okay, so here in example 1, we're going to solve each of these equations simply by converting them from logarithmic form into exponential form. Okay, that's what we're doing here. We are going to be converting to exponential form. And by doing that, we're going to make this equation look 40 times easier, okay? So we simply look at letter A here, log base 7 of x equals 2, and we look at that as being in the form log base b of n equals x, which means b is 7, n is our x, and our x value is 2. Okay, up here, this is what matches up here in this form. So what we do is we convert that into exponential form. When we convert that to exponential form, that is 7 squared equals x. Okay, we simply convert that into exponential form. And everybody in this room can tell me what 7 squared equals. 7 squared equals what? I dropped it in the chat. Yep, 49. So in this case, the answer to the solution would be x equals 49. And I know it can get a little bit confusing when they use the variable x in these equations, and it's also part of the original form. But essentially, all we're doing here is just taking that logarithmic form and turning it into exponential form. And when we do that, it isolates the variable for us, and we just have to solve what's left. Okay? So on the second one here, when we convert that, 5 is the base, 11 is the exponent, that is equal to x. So we convert into exponential form, and then we break out our calculator and we evaluate 5 to the 11th power, which is a fairly big number. So we go here and we put in 5 to the 11th power, and we get x equals 48,828,125. Okay, so we convert it into logarithmic form, and then we use our calculator to evaluate it. Okay, on the final one, the x itself, it becomes our base. So when we convert it into exponential form, we get x squared equals 6. Well, that's an equation we know how to solve. How do we solve that equation? What do we need to do?
Square roots?
Yep, we need to take the square root of each side, which means that our answer would be x equals plus or minus the square root of 6. Except, since x is our base in the original function, the base is not allowed to be negative, so we actually end up excluding the negative version, okay? So we end up excluding that, and our final answer is only the positive square root of 6. X is the positive square root of 6. So again, the big thing here is we convert into exponential form, which will result either in something that goes straight into our happy little calculator or a simple equation that we already know how to solve. Okay? Any questions on converting from logarithmic to exponential form? Grab a picture here to throw into our notes. Any questions before we advance? All right, so that's about half of your homework assignment tonight is converting things from logarithmic form into exponential form and then solving for x. No questions on that before we move forward to change of base? Okay. So your calculator, which is a TI-84 Plus, is only capable of evaluating functions in 2 bases, okay? The first base it can evaluate is base 10, which is known as a common logarithm. Now, the reason why base 10 is the common logarithm is our entire number system is based on the number 10. So our entire number system is based on this number. No, it's going to be on quiz is. Okay? So when we look at a logarithm in base 10, it does not list a base. It just says something like log of 5. Okay? There's no base listed. It's sort of like in a square root. It doesn't show the 2 in a square root, right? The square root of 5, there's no 2 listed, right? It's the same idea. It's like when an exponent is 1, we don't write the exponent because it's unnecessary, okay? So if you see a logarithm and it does not have a base listed, that is a base 10 logarithm or a common logarithm. The other base that your calculator knows how to do are base E logarithms, which are known as natural logarithms. Notation there would be ln of 5. Okay, again, it's not going to show a base because it's a natural log. When we see ln, that's a logarithm with base e. Now, if you look at your calculator, those two buttons, log and ln, are located directly next to the 7 and the 4 on the keypad. Okay, those are the only two logarithms your calculator can do directly, are base 10 and base e. Okay? Fortunately, there's a very simple fix. There's a formula in pre-calculus for logarithms called the change of base formula. It says if you have log base a of b, that is equal to the common logarithm of b divided by the common logarithm of a. Okay? So we take whatever base it's in and we can convert it into base 10 by using this change of base formula. Okay, now we won't always have to do that. If it's already in base 10 or base E, natural log, we can just type it in the calculator and get our value out. Okay, so this next example here is going to have us use a calculator to evaluate 4 different logarithms, starting with log base 3 of 4. Now this is a base 3 logarithm, which means your calculator cannot do it. We have to use the change of base formula. So that will be rewritten as the log of 4 divided by the log of 3. And we just type that into our calculator, okay? We hit the log button, which is next to 7. Type in 4, close the parentheses. Hit divide, then hit log 3 and close those parentheses. So you should end up with log of 4 divided by log of 3. Hit enter, and it will evaluate that logarithm. You should get 1.26. We're going to go ahead and round it. 185 is what we've got. We're going to round it to the 3rd decimal place because why not? That 8 would tell us to round it up to 1.262. Okay? Natural and common logarithms are the only ones we are capable of doing on a calculator. So we use this change of base formula to give us what we need. Now letter B does not require the change of base formula because your calculator can already do natural logarithms. All we need to do is hit the natural logarithm button, which is directly below the logarithm button. It's right next to 4. So hit ln and then type in 5 and close the parentheses. You should get 1.6093. Again, we're just going to round that off to about 3 decimal places. That 4 would tell us to round the value down, and we would keep 1.609. Any questions so far before we do the other 2 examples?
Yeah, number B. Oh.
Okay. Again, the natural logarithm is one of the ones our calculator can do. So if you look at my camera on my other screen here, you'll see I've already got it typed in there, ln of 5. It's probably backwards. But all you're doing there is you're hitting that natural logarithm button, which is right next to the 4. It's right there. You're going to hit that button and then type in 5 and hit enter, and it will give you the value directly. Natural logarithms and base 10 logarithms are the only ones your calculator are capable of doing. Okay? Any other questions that I can help with before we move into these other two examples? Actually, what I'd like you to do is I'd like you to do the other two examples. So I'm going to give you about 60 seconds here, and then I'm going to start into them. So try letter C and letter D. Come up with those values, and then we will go over them. Okay? Take about 60 seconds here. We're going to be done early today, folks, so bear with me here. We're almost done now. Okay, work through those examples. Give you about 60 seconds. Still no golden.
Mr. Wills Jackson's on his way.
Okay. All right, so on letter C is an example of one that your calculator can do. All you need to do is hit the logarithm button and then type in 14 and hit enter. So it's right next to the 7. You hit the logarithm button, type in 14 and hit enter. And as it says in the chat, we're looking at 1.1461. So if we round it the same way we've been rounding the others, you should be answering with 1.146. Letter D is a base 8 logarithm, which again is not something your calculator can do. So you have to use the change of base formula. That would be the log of 5 divided by the log of 8. Remember that the log of the base goes on the bottom every time. So then we type that into our calculator, log of 5 divided by the log of 8. And we are seeing here 0.7739. That 9 would tell us to round that up, so I'm seeing 0.774. Okay. Any questions on these 4 examples before we move to the next thing, the last thing, as it were? No, we're okay? Okay. On to the last thing then. The last thing is the same thing we did before, converting between one form and the other, except now these functions are in exponential form, and we are going to be converting them to logarithmic form. So remember that when we have log base b of n equals x, that turns into b to the x equals n. And it actually goes the other direction as well. So if we look at what we've got there on that first problem, 3 to the x power equals 21. 3 would be our base, and 21 would be our n. So when we convert this from exponential form into logarithmic form, that would be log base 3 of 21 equals x. Well, we just talked about how to do that. That requires a change of base formula. So x would equal, so then we've converted it here. Now we're going to use change of base to get it into something we can plug into our calculator. Log of 21 divided by the log of 3. Feed it to the calculator and get your decimal answer for x. So log of 21 divided by log of 3. Let's see here. That would be 2.7712. So that 2 would tell us to round down. I got a little bit sloppy in my writing there. And we would give the answer that x is approximately 2.771. Try the next one, please. Try letter B. Again, I'm going to give you about 60 seconds. To give letter B a try. In fact, I'm going to give you long enough to give it a try while I get your homework launched. Step 1 in the process, if you're staring at it not sure what to do, is to convert it from exponential form to logarithmic form. In this case, the base of the exponential is 4, so that will also be the base of the logarithm. N becomes the number inside the logarithm, which would be 0.7. So when we convert that to logarithmic form, we have log base 4 of 0.7 is equal to x. Then we do the same exact thing we did on part A. Our calculator is not capable of solving that particular logarithm because it's base 4. So then we have to use our change of base formula. So x would equal log of 0.7 over log 4. Log of 0.7 divided by the log of 4. Type that into our calculator, making sure to close parentheses, and we get negative 0.2572. Again, looking at that fourth digit, because we're rounding everything to thousandths today. That 2 would tell us to round down to negative 0.257. That's as deep as we're going to go into section 3.2 here before break. We're going to keep it relatively simple. So that is it for our notes today.